Okay, in this video here, we're going to have a look at what's meant by activation energy and how we identify activation energy in different types of reactions. So first thing, let's define what activation energy is. And activation energy is the minimum amount of energy needed for particles to react when they collide. So if two particles come together and they have enough energy, then they will react. If the particles come together and they don't have enough energy, then they'll just bounce apart and no reaction will happen. So this is the minimum amount of energy needed for particles to react once they have collided. We need to understand this for two types of reactions. So the first type of reaction is exothermic reaction. Now remember, exothermic reactions, exo is exit and thermic is representing heat energy, thermal. So this is heat energy is being released, So here are the reactants. And when it forms the products you can see here have got less energy, because this is the amount of energy that is being released as those products form. Okay, so that's the first thing, is this is a type of reaction. Second thing is, how do I identify the activation energy? The activation energy is this barrier that you've got to jump over in order for these particles to react, the reaction to happen. Okay, so here, from here to the top of this little bump here, is the activation energy for this exothermic reaction. If particles have got this, they'll jump over this barrier and they will react. If particles don't have enough energy, then they'll come together and they'll come back down and stay as reactants. They won't form products. Compare that to the second type of reaction we need to understand, which is an endothermic reaction. Remember, endo is like enter, so heat energy is going to go in. Therefore, the products will have more energy than the reactants. So my graph is going to look a very different shape already. You can see here. Here's the energy of the reactants. And as we've said, the products have got more energy because they've taken energy in. And this is the amount of energy they've got more than they started with. Here's my activation energy bump. This is what we've got to get over in order for the reactants to form the products. And again, we can mark it off from here to the top of this bump is a measure of the activation energy. And if particles don't have this, they're not going to react. They'll just come back down and stay as reactants. So here the key things are understanding what is meant by activation energy, and then being able to identify where the activation energy is on a particular energy diagram like we've got here.